Ready?
Yes.
So back when you have to say action,
Okay.
snap the thing. Okay, so back whenever I was first taking physics, my professor said that the way to read a problem was to read it once and kind of get a sense of the story that's happening in the problem, and then read it again and list everything that's known and unknown, and then look at your list of everything that's known and unknown and look for a formula that would work to help you find it. So me personally, whenever I read these, I find that the numbers get in the way, so I don't pay much attention to them. So this one I'll say, suppose a car travels some distance at some speed and uses some amount of gasoline. Only a certain percentage of the gasoline goes into useful work by the force that keeps the car moving at constant speed despite friction. And then they tell you how much gasoline has how much energy. What's the magnitude of the force exerted to keep the car moving at a constant speed? Okay, so this story is about a car, and it's got a certain distance and speed. It's like it's a car traveling somewhere, and they're asking stuff about that. So now I've got the story of what's going on. Now I'm going to read it again. Okay, so we've got a car traveling 108 kilometers. Kilometers is a measure of distance. And then we've got a speed of 30.0 meters per second. Meters per second is a measure of speed or velocity. Now the difference in speed or velocity is that velocity has direction and speed doesn't, but speed still gets the abbreviation V. If it's velocity, then it has a little arrow over it. I always forget to put that arrow too. I'm bad. Okay. And uses 2.0 gallons of gasoline. Gallons is a measure of volume, like a gallon of milk. And that's not one that we put on here. Gallons. We'll have to think about that one later, because I know there's other ones, but volume. And I guess volume, the volume question would be how much? How much could be money, though? Like, how much does that cost? I don't know. Okay. Only 30% of the gasoline goes into useful work by the force that keeps the car moving at constant speed despite friction. That's a mouthful. But I'm going to write down 30%. And it doesn't really have anything that it goes with, but I'm thinking about this. Only 30% of the 2 gallons. I think we might need to change 30% into a decimal and multiply it by the 2 gallons, maybe. Only 30% of the gasoline goes into useful work by the force that keeps the car moving at a constant speed despite friction. Well, so we know we've got friction that pushes back the other way, but when they talk about useful work by the force that keeps the car moving, I automatically think about the first 2 questions in this handout where they wanted to emphasize that force and displacement have to be in the same direction in order for there to be work. So I wonder if they're kind of mentioning that here. And so they say 1 gallon of gasoline. They give us a conversion here. So 1 gallon of gasoline. It says it contains, I'm going to put equals 1.2 times 10 to the 8th joules of energy. And then they say, what is the magnitude of force? So force equals question mark, exerted to keep the car moving at a constant speed. So this problem is a little bit complicated. I'm thinking that we take this 30% and apply it to the 2 gallons, and then whatever gallons we have left, we convert that to energy using this conversion. Not energy, work. Which in a sense is energy, but we've been calling it work. And then once we have work, we can use this formula, or this formula. Probably not this one though. To find our force.